power grid. So the power grid is something that I think many sort of take for granted, right? We switch on a light, and unless there's a planned or unplanned outage, hopefully the light will come on. And yet behind that, it's a very complicated system. It's a system where the amount of power that is being produced and put into the power grid has to exactly equal the amount that is being consumed on the power grid at every single moment in time. And this is incredibly complex because, first of all, we have a lot of variation in how much demand is on the grid at any given time. And as we aim to work towards kind of decarbonizing power grids or moving to more distributed forms of power, we also have to deal with the fact that the amount of supply we have, solar and wind, for example, varies based on the weather. So how do we manage this kind of increasingly complex system? We've historically done this using kind of optimization, electrical engineering, controls, paradigms where we actually write down explicitly the sets of equations that we want to solve over on the system and solve them. But the challenge is that this paradigm is not sufficiently scalable. It's much too slow to solve the problems we actually need to solve to coordinate the power grid. And so this is where AI can potentially play a role in terms of both helping us reduce the uncertainty of quantities like demand and renewable energy by helping us to forecast these quantities more effectively. Then given those forecasts to help us to actually control the different devices on the power grid, our power generators, our batteries, our inverters, in ways that are more scalable. So